Okay, so we're back here, and I have my intersection points. What I've done here is I've told, and you remember when you're doing the AP, you want to make sure you show them what you're doing. So I have my two equations equal to each other, and then I just give the solutions. So when it's a calculator active problem, you don't need to show all the algebra to get there. You just need to show the AP graders. I set the two equal to each other, and then you have your x values. So right now you can see, right here's my rough sketch from my graphing calculator. I just used, graphed both of them, found the intersection points, and just took the x values of those. That's what I did. Right? That's my preferred method for solving. But I know some people like to use a solver to do that too. So anyway, so for each region, things are going to be a little different because you can see that it jumps over itself. So for this one, there's my sliver of a rectangle, and I'll shade it in for myself. Okay, you can see the thickness of it right here is the base of it is dx, and then the height there, right? That's our change in y. And we can see our top function there is the x minus 1, and the bottom function is this cubic function for myself. So that's the area of that rectangle. And if we want to do the infinite number of rectangles, it would be between negative 5.62 and 1, and then we would have that x minus 1 plus x cubed minus 4x squared plus a 3 dx. Okay. The second region here, right, if I drew my rectangle in for myself, here's the rectangle and find the area of, right, again, still dx is my integral, as my base there, so I'm integrating in terms of x. And then the height here is a little different because you can see the cubic function's now on top, so I'm going to take the cubic function for myself, okay, and then subtract the lower function. Remember, it's the top minus the bottom there. Okay, so those are my two functions for myself, right? The dx afterwards. My bounds being from that intersection at 1 to the 3.562. Okay, at this point you really, it depends on what the problem's asking you. I know this problem said find the area between it. If we're going to do that area, because we've got these weird wacky numbers here, we'd probably just be doing it on our calculator. The most important thing to notice is that which function with the larger function changes because there's the two different regions for yourself. So personally, I always like to do the top minus the bottom. I don't like to change any signs here. I know we saw that in an earlier example, but I would just do that. All right. So this right here, if you're thinking about the AP, and it's a lot of times they just say that to set it up, that one's done. If you have to integrate it, you just put in your calculator and get an answer. But I'm gonna stop. I'm gonna skip ahead to the next one. Just got to go through the concepts here as we do these. If I'm looking at 5, definite integral for the graph at right is what? Okay, so if I think about my sliver here, right, I draw that in. Okay, the top function is the sine of x, so it's a change in y, so it's the top function minus the bottom one, which is negative x. Okay, so because of that double negative there, that's going to become a plus. Okay, so that gets rid of a and c. Right, so we just have b and d. We just have to figure out what are the bounds. Well, if we're looking at it, the x goes from 0 to pi, so that's why it's b there. Okay. For the next one, a definite integral for the area. Right, it's not graphed for us, so I'm going to make a quick sketch here. Right, and you don't have to be perfect. Just need to remember, like x squared. Right, its vertex is at 0, 0, so it's going to open up. And then this is y-intercept at 2, and it's opening down, so it's going to kind of be like this. Okay. In class on Friday, I talked a little bit about using symmetry if you can. This one we could use symmetry because this area and this area are congruent. We could do half of it and then double the answer at the end. But we'll kind of see, since it's multiple choice, we kind of have to see what they want us to do, and then we'll kind of make our answer match that. So where are the intersection points here? Let's see, so we got 2 equals 2x squared, so x squared equals 1. So x equals plus or minus 1. Okay, so that looks like A and B might be our correct answer. Just have to see how, if they fit with the height of the rectangle. So my rectangle here is going between the top to this right here is the change in y. That's the height, and so it's going to be 2 minus x squared minus another x squared. So it's 2 minus 2x squareds. Okay, so that's the height of my rectangle, and my width is dx, right? How wide is it, dx, and right, how tall is it, the top minus the bottom. Okay, so it looks like this one's going to work then between -1 and 1, right, for myself. So there's my answer. I guess again, we're just setting up, we're not integrating. Okay, so at this point the notes are done, and now we can talk about how to do some of these homework problems, and I'll try to fit these on here as best I can and within reason. Alright, so number 1 here, the diagram opposite shows the curve. Okay, right, so find the coordinates of A and B. Okay, so that's our intersection there, so we're going to do that. Right, 4x minus x squared equaling 3. Right, so x squared minus 4x equals, plus 3. I moved everything to the right, and so if I factor that, I get x minus 3 and x minus 1 equals 0. So I get 1 and 3 as my two x values. Okay, so find the coordinates of A and B. 1 comma 3 and 3 comma 3, and I'm putting the coordinates there. That's why I'm putting the y value. So there's your x, there's your y. Okay, now let's calculate the shaded area. So if I'm thinking about my sliver, there's my sliver. Its width is dx. Its height is the change in y. That's how tall it is, which is the top minus the bottom. The top function being 4x minus x squared. The bottom function being just 3. Okay, and we're going to integrate that from 1 to 3 for dx. Okay, before I integrate, actually I guess I could just integrate as it stands because there's no like terms there, so I'll do my antiderivative. Okay. Here's my antiderivative. And as always with this, with integration, you don't always have to do the antiderivative. If you can find the area under the curve, that's great. But I'm just going to do antiderivative for this one. At this point, I'm going to plug in. So I'm going to, let's see, so that first number is going to be, I'm doing f of, big F of 3 and figuring out what that is. And so big F of 3, that's going to be 18, right, minus 9, minus another 9. Okay, and then I'm going to subtract the lower bound, and I'm going to put it right below here, right? And that's going to be, let's see, if I plug in 1, that's going to be 2 minus 1/3 minus 3. Okay, and I'm just putting it underneath. Sometimes that helps me with canceling things out. Let's see, that gives me 0, and this one down here, right? 2 minus 3 is negative 1, minus another 1 is negative 1 and 1/3, but then opposite of that. So we have 1 and 1/3 as our area there. If you want to write it as 4/3, great, good for you. And I'm just going to leave it as 1 and 1/3. Right? It doesn't really matter how that answer is left. Okay, looking at number 2 here. Right, y equals x squared. I know it doesn't. That copy wasn't great there. Right, but it's still going to work for us here. So. Right, there's my rectangle, so I'm going to do the x squared term minus the 2x squared, minus 25 dx. Okay, where are my intersections? Okay, so x squared equals 2x squared minus 25. So that's going to give me that the intersections are plus or minus 5. Okay, plus or minus 5 for those. So, okay. Now, again, I talked a little bit earlier about like, hey, if there's symmetry, you can have the two sides match. So instead, if you want to do symmetry, right, you could do for your bounds 0 to 5 for that same area. Okay, but then you would just double the whole thing. So if you know that the two sides match up, it sometimes is easier for you just to use 0, because 0 is a great lower bound, right? You don't have to really worry about it. So that's why that's a little bit better way to solve this. Okay, and I say better, but it's not. You don't have to do it, but I'm going to do it just to show you how much better it can be. Okay, so there's that. When I distribute the negative, right? So that's why we get that becomes positive. My antiderivative. Okay. Times 2, bounds from 5 to 0. Okay, nice part is I'm not even going to have to worry about plugging in that 0 because it's going to make that lower bound, right, 0. So I just really have to do the upper bound there and then scale it by 2. Okay, I'm going to put my final answer, right, I'm going to put it over here so we can find it. So 2 times, and then negative 125 over 3 plus 125. Okay, and that's just, you look at it, man, that seems so much easier, doesn't it? Right? Making a common denominator here, this is 375 over 3. Right? If I make that common denominator, so I have 250 over 3 times 2, so that's why it's 500 over 3. Okay? For myself. Right? That's the area between the curves. Okay? As you're looking through these videos, remember that if you don't need an explanation, just skip ahead. Right? You'll find the explanations later. You just kind of use what you need to for these videos. They're just set up to help you to explain things, especially if you weren't there on Friday. Okay, so let's see, next one. Right? No symmetry here, so I'm just going to have to do it as it stands. Minus the lower bound, dx. Okay. Right. Okay, I have some like terms, so I'll combine those. So I'm going to have 4x's minus 2x squared dx. And then I just have to figure out where those bounds are going to be there. So we can see that one's at 0. That's nice and easy. So if I set 3x equal to 7x minus 2x squared, okay, 2x squared minus 4x equals 0. Factor out the 2x. So the other intersection's at 2. So great. So we have 0 and 2 as our bounds. Okay, do the antiderivative. Okay, between 0 and 2. Let me just double check. Okay, yep, those look good. Plug them in. Right, so that's going to give me 8 for this one. Right, minus 2/3 times 8 there. So the lower bound 0, so that's again a nice one. So if I make it thirds, then I have 24/3 minus 16/3. So my overall answer for this one is going to be 8/3. Right, and okay, 8/3 is my answer there.